Again, welcome back to Calculus. In these lectures, we are going to learn the concept of linear models and rate of change. Now, rate of change will be learning how to find a slope. So our first objective is to find the slope of a line passing through 2 points. Also write the equation. Also write the equation of a line with a given point and slope. So we start with the slope. Now we said a slope of a non-vertical line is a measure of the number of units the line rises or falls vertically for each line of the horizontal change from left to right. Now, anytime we want to find the slope of a line, we are just going to take 2 points on the line. Now, here we mention non-vertical line because you can see if we have a vertical line, the value of x will be the same. So the value of s1 and s2 will be the same. And we'll explain that later on from the slope formula. So here we take any 2 points. Let's say here we have s1, y1, because this is a 2-dimension, x-axis and y-axis. So each point may have only 2 values or coordinates. So s1 and y1, point 2 is s2 and y2. So the first thing we need to do here is to find the changes between the y's, the y2 and y1, and also here the change between s2 and x1. So we call the change of in y as dy equal to y2 minus y1. The x will give us s2 minus x1. Next, we are going to find the slope. So normally the slope will be the y divided by dx. As we said, the y is the change of y values, which is y2 minus y1. The x is the change in x value, which is s2 minus s1. So our slope formula will be y2 minus y1 divided by s2 minus s1. Here we say that s1 is not equal to s2. When s1 equal to s2, we're going to get a vertical line. A vertical line means any value divided by 0 is undefined. There's no absolute answer. So that's the formula again. It's the same as previously we say y2 minus y1, s2 minus s1. It's the same as saying y1 minus y2, s1 minus s2. But we cannot say y1 minus y2 divided by s2 minus y1. y2, s2 must be the same. So these examples of few properties of a slope. So here we can see that we have a line. The line rises from left to right. So this will give us a positive value for the slope. Now we have horizontal line. Horizontal line means the y value is constant. So this means y2 minus y1 will be 0. As we can see here, 2 minus 2 is 0. Now any value, 0 divided by any value will give us 0. Now when we have a force from left to right, as we can see on this diagram, our slope will be negative value. So the rise from left to right on the line will be positive value for the slope. A line falling from left to right, the slope will be a negative value. And as we said earlier, vertical line, there's no slope value. So M is undefined. So next we go to equation of line. So we also use the slope formula to find an equation of a line. If 2 points, so here we say any 2 points on a non-vertical line can be used to calculate the slope, as we did previously. So now when we look here, we can see, as we said earlier, a slope, the difference of we can, for example, here we have 4 points. We can take any points, 2 points. And if I take the first 2, or the first and the last, we get the same solution. Now here, we use the slope formula to find an equation of a line. So here, for example, we know slope, as we said earlier, is y1 minus y2 over s1 minus s2. But here we say y minus y1 over s minus s1 equal to slope. When we cross multiply, we get y minus y1 equal to m times s minus x1. And this is what we normally call the point slope form of the equation of a line. So again, the point slope form of an equation of a line is y minus y1 equal to m times x minus s1. Normally, a point will be given to us, which is y1 and x1, and also a slope will be given to us. If a slope is not given to us, then 2 points will be given to us to find the slope. So that's a good example here. Find an equation of a line that has a slope of 3 and passes through this point. So here the slope is given, the point is given, which is s1 and y1. So we can find the slope of a line. We write this is in a point slope form. So it will be y minus y1 equal to m x minus s1, a point slope form of an equation of a line. So we plug in the value y minus y1 is -2, m is 3, x is 1, s1. So our final equation will be y plus 2 equal to 3s minus 2. And we can bring the plus 2 to the right, which will be -2. -2 minus 3 giving -5. So y equal to 3s minus 5. So to sketch the line, first we plot the point 1 and -2. Then because the slope is 3, we can locate the second point on the line by moving 1 unit to the right and 3 units upward because it's +3. So this gives us our second point here. We move 1 unit to the right, 3 units to the. So now if we know the second point, then we can solve the problem. So next is the ratio and rate of change. So we see a slope of a line can be interpreted as either a ratio or rate of change. As we can see, the steepness of a line is the rate of change, and the change will be constant. Now in the future, we'll cover how to find the slope on non-vertical and non-linear. So our line is a linear constant. But if you have non-linear, let's say for example, polynomial function, again the slope may not be constant. So here we say if x and y axis have the same unit of measure, then the slope has no unit, so it's a ratio. Now if x and y axis have different unit of measure, then the slope is a rate or rate of change. So that's all we mean by a slope can be a ratio or rate of change. So example given here we say we have a maximum recommended slope of a wheelchair ramp is 1/12. Now a business installs a wheelchair ramp that rises to a height of 22 inches over the length of 24 feet as shown in the diagram here. So we can see the right 22 inches, length 24 feet. So here the question now said, is the ramp steeper than recommended? So we need to find it. So we say the length of the ramp is 24 feet. Or we can say 12 times 24, we change it to inches, 288 inches. So the slope of a ramp is the ratio of its height, which is the rise, and also its length, the run. So we have rise over the run. The rise is again like y. So in the diagram here, let's go. So we can see the rise will be 22 inches and the run 24. So that's why here we have 22 divided by 288. Now the reason why we change the 24 feet to 288 because the rise is in inches, so we have to have the same unit. So here we calculate, we get roughly 0.076. So because the slope of a ramp is less than 1/12, that is 0.083, the ramp is not steeper than recommended. So know that the slope is a ratio and has no units. In this case, the slope is a ratio. So another example given, a population of Oregon was about 3,831,000 2010 and about 3,970,000 in 2014. Here they say we should find the average rate of change of the population over this 4-year period. What will the population of Oregon be in 2024? So here, now if the change is constant, so first we find the rate of change in population, change in years. Now change in population is from 3,970,000 to 3,831,000. So change. Then remember, so I would say 2014 will be S2. At the present, 2014 is 3,970,000. 2010, it was 3,831,000. So we solve this problem. It's okay. The change is increasing within from 2010 to 2014. Average the population increased by 34,570. So here we see, assuming that the Oregon population continue to increase at the same rate for the next 10 years, then we are going to use that slope concept to have 2024 population of about 4,318,000. Again, based on the slope value, we're able to find it. So the rate of change found in example 3, we call it the average rate of change. The average rate of change is always calculated over some period of time, or here we say over an interval. So that will be the conclusion of these lectures. Again, wish to see you in the next lectures. Thank you.